Hello children, we are going to start the first chapter, relations and functions. This is just the continuation of what you have studied in standard 11. That is, in standard 11 you studied the chapter relation and function. So it's just continuation we are going to do. So before continuing further, first of all let us recollect what we have learned in standard 11. There we have learned the points, that the concept about relations, and its domain, range, codomain, and finally we studied about function also. So first of all we will discuss once again what is relation. We can say relation is a subset of cross product. What is cross product? It is the product between two sets. So let us consider an example for cross product. Let A is a set is given 1, 2, 3 and B is equal to set 2, 3, 4. Then we can write A cross B, that is the Cartesian product A cross B. We can write it as like a 1, 2, 1, 3, 1, 4, and then similarly the 2. So that is just like a 1, 2, 1, 3, 1, 4. Now the 2, 2, 2, 2, 3, 2, 4, 3, 2. 3, 3 and 3, 4. So here if you observe the total number of elements, say you will be able to see 9 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. Another way we can say the set A is having 3 elements and the set B is also having 3 elements. Ultimately A cross B will have 3 into 3. That is 9 elements that you have studied in standard 11. And one more thing you studied, that is how many subsets can be written for a set. For example, this set is having 3 elements. The number of subsets for this set is 2 to the power 3. So the same way if you come to A cross B, the number of subsets for this A cross B is 2 to the power 9. Since there are 9 elements, the number of subsets will be 2 to the power 9. In other way we can say that 2 to the power 9, that can be written as 2 to the power 3 into 3. Here 3 elements, here also 3 elements, so ultimately 3 into 3. So in general, suppose A is having m elements and B is having n elements, then the total number of subsets of A cross B, is 2 to the power m into n. So that is the total number of subsets, and we know relation is a subset of A cross B, that is a cross product. Naturally, the number of relations, total number of relations can be written. Total number of relations will be 2 to the power m into n, where m is the number of elements in the first set and n is the number of elements in the second set. So this you have already studied, that is the total number of subsets. Total number of subsets of this cross product is 2 to the power m into n. That is, we can say the number of relations from A to B is 2 to the power m into n. That's the general result that you have to remember it. And another thing you studied about, if you come to this relation, this cross product, if you look at this cross product, here I am going to say one relation. Here I am going to say a relation. I am telling you a relation is equal to. Is equal to means the first component is equal to the second component. That means we can say x coordinate is equal to y coordinate. X component is equal to y component. Such a type of elements I am going to pick up from this. So if you look at here, first of all you can see that 2, 2, 2 2 is there. Again if you come to the same time 3 3. So these are the two elements. Here you can see only two elements satisfying the relation is equal to. So this is a relation. I said a relation here 2 2 3 3. Naturally you can see this is a subset of cross product. So that is why we said relation is a subset of cross product. Okay, now I said a relation. Now the next point you studied about what is a domain. Domain means the collection of all the first components. The collection of all first components. So here you can see the first components are 2 and 3. So the domain of this relation is 2, 3. That is collection of all first component. And what is the range? Range is collection of all second components. So range here, range of this I can write it as here collection of second component, that is 2, 3. So here range, this is domain and this is range. Now what is codomain? Codomain, here I said the relation I said from A to B. Relation I said from A to B. So all the elements of the second set, that is B, that is the codomain. So that naturally the codomain of this relation is 2, 3, 4. Since I defined the relation is from A to B. So these points all you have studied in standard 11. Now we will come to standard 12 portion. So there first of all we are going to discuss about the types of relations. Types of relations on a set. So the first one is what is a reflexive relation. Reflexive relation. Reflexive relation means it's a relation of an element with itself. Relation of an element with itself. See, for example, we can say that in geometry you studied that a triangle is congruent with itself. A triangle is congruent with itself. Or we can say that a line is parallel to itself. Or we can say, if you come to the number system, we can say the number 5 is equal to 5. So such a type of relations is a reflexive relation. That we can write like this. An element is related with itself. We can write like this x. We can write like this x related with x. X is related with x. Or it can be written like this. X comma x belongs to R. For all x, what is this x? This x belongs to the particular set. So the for all x belongs to the given set. See, here I said about the types of relation on a set. So this set only this one. So all elements of that set are related like this. X is related with itself. So such a type of relation is a reflexive relation. And next one is symmetric relation. Symmetric relation is the relationship between two elements. For example, suppose one element x is related with y, then y is also related with x with the same relation. So here again examples if you take, like in the case of similarity, we know a triangle 1 is similar to triangle 2, then naturally triangle 2 is similar to triangle 1. Again, if you go for parallel lines, L1 is parallel to L2, then L2 is parallel to L1. This type of relations is a symmetric relation. So that is the second one, symmetric relation, and the next one is transitive relations. In transitive relation, we have to see three elements. We have to look for three elements. Suppose the relation is like this, like x is related to y and y is related with z, then x is related with z with the same relation. For all x, y, z, for all x, y, z belongs to the particular set. So this type of relations we will say transitive relation. So for example, if I take some numbers, certain numbers I am taking like 3, 5, 8. We know that 3 is less than 5 and 5 is less than 8. Naturally 3 is less than 8. So I use the relation is less than. So 3 is less than 5 and 5 is less than 8. Naturally we know that 3 is less than 8. This type of relations we will say transitive relation. Transitive relation. Transitive relation. So first of all I said about reflexive relation, that is an element related with itself. And when it comes to symmetric relation, we can write x related to y, then y related with x. If I write in ordered pair form, that can be written like this. Like if xy is there, implies there should be yx also in that. If xy is there, then there should be yx also in that. Now the last one I said about the transitive. Here also if you write in ordered pair format, xy and yz implies xz must be there. Then only it is a transitive relation. xy, yz, then xz also must be there. Then it is a transitive relation. So these are the three types of relations: reflexive, symmetric and transitive. Now if a relation is reflexive, symmetric and transitive, then it is known as equivalence relation. So now based on this only, these things plus what you have learned in standard 11, based on that only your first exercise of this chapter. So now we will try to do few questions from the first exercise. That is exercise number 1.1. First of all, we will try question number 3. In question number 3, this question is like that: R is a relation defined on the set of natural numbers. Its meaning is only R is defined from natural number to natural number. Okay, defined on set of natural numbers such that R is equal to, it is given like this: R is equal to set of what x, y, such that 2x plus y is equal to 41. X comma y belongs to n natural numbers. So this the relation is given from natural number to natural number. So it is given like this form, that is in Centimeter form. Now question is, we have to find out the domain and range of the relation. First of all, we have to find out its a domain and range of this relation, and then we have to determine whether the relation is reflexive, symmetric and transitive. That is the question. So first of all, we have to go for the domain and range. So for that, take this equation part, that is 2x plus y is equal to 41. Here I am making y subjects according to our convenience. We can make it y I am making subject 41 minus 2x. Now I am putting the natural number. We know x and y are natural numbers, so I will put the natural numbers. I am going to put the value of natural number starting from 1 onwards. So when x is equal to 1, if I put x here 1, 41 minus 2 into 1 is 2. So 41 minus 2 is 39. So this you can do manually. So first I will write it. When x is equal to 1, this implies the value of y, we are getting it as 41 minus 2, that is 39. So the first element I can write it as 1 comma 39. That is I am writing here 1 comma 39. Now the second part is the first element. Now the second natural number 2 I am putting it 41 minus 4. 41 minus 4, that is 2 I am putting. So 41 minus 4 is 37. Next 3, it is coming 5, 19. So if I put here 38, so it is 3, 20, 19 after 19, 20 I put, so 41 minus 40, that is 1. Now 21 if I put 41 minus 42, it is negative number, that is not a natural number. So that means we cannot go for any more. So it will go up to here. So these are the elements of this particular relation. These are the elements. So I wrote all the elements. So it is given x and y natural number. So we have to stop here. If I go for 21, here it is coming negative number, that is not a natural number, so we cannot go further. Now the question is, what is its domain? Its domain, we have to go for collection of all x coordinates, that is the first component, that is domain. Domain is equal to here, you can see 1, 2, it goes till 20. That is the domain, that is collection of all first components. And now what is its range? Range is the collection of all its second components. Second component, if you see in order 1, 3, 5, 7, 9, it goes till 39. So 1, 3, 5, 7 till it comes to 39. That is its range. So domain and range, that is the first part of this question. And then they are telling in the same question, find the domain and range of the relation R. The first part it is over. Second part we have to find out whether the relation is reflexive, symmetric and transitive. So we have to look whether it is reflexive, symmetric and transitive or not. So we know in reflexive we need an element is related with itself. See, for example, if you come to here, the first element is 1. So 1 must be related with the 1. Look for any such element, 1 related with the 1. There is no such element. So 1 must be related with the 1, even 2 must be related with 2, like that, all it must be related like that. So therefore, we can say that this is not reflexive, because we can say like this, the element 1, 1 does not belong to R. So 1, 1 does not belong to R. So therefore, R is not reflexive. R is not reflexive. Okay, that is x comma x does not belong to R. So it is not reflexive. Now the next one, whether it is symmetric or not. We know symmetric, if x related to y, then y must related with x. See here 1 comma 39, then we need 39 comma 1. Is there 39 comma 1? There is no 39 comma 1. So therefore this is not symmetric. See even 3 comma 35, so we need 35 comma 3. Even 2 comma 37, we need 37 comma 2. So there is no such element. So we can say it is not symmetric. So how we can write it? Go for just one element if you take like 1 comma 39. 1 comma 39 belongs to R, but 39 comma 1 does not belong to R. Therefore R is not symmetric. Therefore R is not symmetric. Now we have to go for transitive. Look at transitive. We know we can see two elements like 12 comma 17, 12 comma 17 and 17 comma 7. If you look at these two, 12 comma 7, that is x related to y, y related to z. So we need x related to z. See 12 comma 7 we need. There is no 12 comma 7 in this. So that is why we can say that we can write like this: 12 comma 7 belongs to R. 12 comma 17 belongs to R, and 17 comma 7 belongs to R, but 12 comma 7 does not belong to R. Therefore, R is not transitive. R is not transitive. So therefore, in this case, this relation is not reflexive, not symmetric, and not transitive. So that was the question. That is question number 11. Here the question is given that prove that the relation R in the set A is given by, that is R is defined, the relation R is defined from A to A, and it is given A is equal to, they are given, the set A is already given 5, 6, 7, 8, 9. This is the elements of the set is given and relation set from A to A. And R is equal to, so therefore A is such that modulus of A minus B is divisible by 2. We have to prove that this relation is an equivalence relation, and also we have to find out all the elements related to the element 6. So that is the question. First of all, we have to prove that the relation is an equivalence relation. It is a relation set from A to A, and the elements of A is 5, 6, 7, 8, 9. And relation is given modulus A minus B is divisible by 2. So first of all, we will write the elements of R under this relation. So first of all, if I put we know for getting the relation, first of all we have to look for the cross product, that is A cross A, we have to do it. So naturally there will be 5 into 5, 25 elements, but we look for only this case. We don't have to write all those things. So first of all I will see with the 5 minus 5. If I put the first element will be 5, 5. So 5, 5, if I put 5 minus 5 is 0, is divisible by 2. So that is possible. So 5 minus 5, that is 5 comma 5, that is first element. Now with the 5 we go for 5, 6, if you take 5 minus 6, that is minus 1 modulus, so it is plus 1, not divisible by 2. But 5, 7 if I take 5, 7, 5 minus 7 minus 2 modulus, it is plus 2, it is divisible by 2. So the second element is 5, 7. Now 5, 8 is not possible, 5, 9 is possible, since 5 minus 9 is divisible by 2. Now with the 6, if I go first one, 6, 5 will come, but that is not possible. 6, 5, 6 minus 5 is 1, that is not possible. 6 minus 6 is possible, so second element 6 comma 6 is possible. 6, 7 if you put, that is not possible. 6, 8 if you put, it is possible. So 6, 8 is divisible by 2. Now 6, 9 if you put, that is also not possible. Next we will try with the 7, 5. 7 minus 5, 2 is divisible by 2, so 7, 5. Now 7, 6 is not possible, 7, 6. Then 7, 7 if I put, it is 0, so divisible 7, 7. 7, 8 is not possible, but 7, 9 is possible. Now we will go with 8, 5, if you put 8 minus 5, that is 3 is not divisible by 2, 8 minus 6 is possible, 8, 6, 8, 7 is not possible, but 8 is possible, 8, 9 is not possible. Now what about 9, 5 is possible, 9, 5, 9, 6, difference is 3, not possible, 9, 7 is possible, 9, 8 is not possible, 9 is possible, 9 minus 9 is 0, 9 minus 9 is 0, so that is also possible. So these are the elements of this relation. So first of all I wrote the elements of this relation. by looking at this element. Actually it's all selected elements from the cross product, from the Cartesian product. Now we have to see, we have to prove the question is an equivalence relation, so we have to check whether it is a reflexive or not. Reflexive means an element must relate with itself. You can see that here 5, 5. If you look at these elements, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. It is just like x related with x. So therefore the relation is reflexive. We can say that here x related with x related with x for all x belongs to the set A. Therefore the relation is reflexive. Therefore the relation is reflexive. It is reflexive. Now we have to go for symmetric. If you look at 5, 7, then we need 7, 5. Let's see, 5, 7, 5, 7 is there. Yes, 7, 5 is there. Like there are all elements, you can say 5, 9, 9, 5. So therefore, we can say that x related with y, then y is also related with x for all x comma y belongs to the set A. Therefore the relation is symmetric. So it is reflexive and symmetric. Now we have to check it whether it is transitive or not. So for that, let's see few elements. It must be like this: x related to y, y related to z, then x must relate with z. See, let's see, like I'm looking for 5, 9, then 9 is related with 5, you can say 5, 9 is related to 5, then we need a 5, 5, so it is there 5, 5. Or if you go for another like 5, 7, then 7, 9, 5, 7, 7, 9, then we need a 5, 9. Is there 5, 9 is there or not? Check 5, 9. Yes, 5, 9 is there. 5, 9. So 5, 7, 7, 9. So 5, 9. Therefore the relation is transitive. That means we can say that here x related to y and y related to z implies x related to z for all x, y, z belongs to A. Therefore the relation is transitive. Now since the relation is reflexive, symmetric and transitive, it is an equivalence relation. All the three is reflexive, symmetric and transitive. Therefore the relation is an equivalence relation. And here one more part was there. We had to find out the elements related with the 6. Elements related with the 6, if you see here, elements related with the 6. This 6, elements related with 6 is here, this 6 is there. And again in more place, elements related with the 6 here we can see 8. So the elements related with the 6, we can see there are two elements, 6 and 8. So that is the last part. The elements related with the 6 is set 6, 8. Okay, this is the question number 11. Rest of the questions from the exercise you can do it as homework.